We're ready to go. I've got the usual problems with the dropout of Fred's audio, but it seems I'm the only person in the world that ever suffers from that because, and I don't know why. And the other thing is Fred's VU mood is frozen, but it says it's uploading, so that's all good. And everything else seems to be okay. I've got all my bits and bobs. I might do a test on my desk because I haven't touched it in a month. So
Space Nuts.
That's working. That's all I needed to know. Okay, shall we do the TikTok, Fred?
Let's do the TikTok.
Okay, here we go in 3, 2, 1. Hi there, Andrew Dunkley from Space Nuts, the podcast about astronomy and space science. We've got a couple of new episodes coming up for you soon, episodes 409 and 410. And joining me will be Professor Fred Watson, astronomer at large, back from the big smoke, or the United States, if you prefer, after witnessing the eclipse. Hi, Fred.
How are you doing, Andrew? We didn't see much smoke at all, I have to say, unlike the last time we were in the USA when there were bushfires. So we did see.
Yes. Yes. Yeah. We're going to talk about the eclipse in the episode, no doubt. But what else is on the agenda for the next couple of episodes?
So we'll talk about my trip because there's lots of spacey stuff that happened and some good news for Space Nuts as well. People listen over there. And we'll also talk about a black hole that has been discovered not very far from our solar system, 2,000 light years, which is a record breaker. It's the biggest stellar mass black hole known in our galaxy.
Otherwise known as a credit card, yes. And in our Q&A episode, we'll be looking at questions about black holes. We'll also be talking about supernovae and how they create elements, the Fermi paradox, and the effects of time travel and magnetospheres. Those are some of the things people want to know about on our upcoming episodes. Fred, I've got probably one of the worst dad jokes I've ever had to tell you. What did the star say to the moon who was having a tantrum?
Oh, you're a loony.
No, that's good. Stop your whining. Yeah.
Like
horrible.
Stop your whining. Yeah.
Yeah.
So
you got
yes,
one?
I do. What are alien pets called?
Ooh, Osiris Rex.
Oh, I like that. No, they're extraterrestrials.
Oh, horrible. And if you dare, please join us on our upcoming episodes of Space Nuts, coming to a podcast platform near you soon. Oh, thank God that's done.
Yeah, it's embarrassing, isn't it? Why do we do it?
That warbling in your voice is terrible today at my end. I wish I could figure out what's causing it. It's not bandwidth. It's not a bandwidth issue. It's something else, and I don't know what.
Something Riverside.
It could be, but they're playing politics. They deny it. But I don't know. Could be something else. Let's get this show on the road, shall we, Fred? All right, here we go. In 3, 2, 1. Hi there. Thanks for joining us again on Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley, your host. It's always good to have your company. Thanks for joining us. Coming up today, we are going to talk about Fred's trip to the US, where he saw eclipses, he saw rocket launches, he saw dogs and cats living together. There were all sorts of things happening. And we will be revisiting that little tour because some pretty exciting things happened. And this wasn't exciting. This was probably a bit harrowing. Space junk hitting a house in Florida. That doesn't happen often. And probably one of the biggest stories in recent weeks or months, the most massive stellar black hole yet found in our galaxy. We'll be talking about that. And on our upcoming, well, that's it. We've got it. I keep forgetting we've split the show in two. So I'll tell you about the Q&A episode later. But those things coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here he is, fully jet lagged and ready to go. Professor Fred Watson, an astronomer at large. Hello, Fred.
Who are you again? I
What day is it?
Yeah, that's right.
And the other thing, I didn't realise overnight television was so horrible. That's the other thing that jet lag teaches us.
Yeah, no, I haven't gone there. It's not been too bad actually. It's coming this way. I think is a little bit better than going the other way.
Definitely.
We lost Friday the 12th of April. That disappeared over the dateline. We didn't see any of that, which was all right.
It's just a weird thing, isn't it? Though you take off on a Friday and you get home on a Sunday and you go, "Hang on, what happened there?"
Yeah.
It's such a strange thing. But going the other way, you sometimes continue to live the same day for like 36 or 40 hours.
Yes, that's right. Yeah,
it's truly bizarre. But that's one of the first world problems we deal with.
Indeed, it is. But
era.
yes, thank you. We're fine. Really, still in a way, still processing this marvelous journey that we've had. Over in North America. So we started off in Vancouver, in Canada. I have never visited Canada before, and I knew I'd be impressed, and I was.
It is a lovely place.
Yeah, especially British Columbia, where we were. Took in the snow up there as well, all sorts of things. We went up by train to Whitehorse, which is subarctic. It's in Yukon. One of the highlights of that train trip was a lovely couple of who turned out to be from the Central Coast in Australia, who came up and said, "Are you Fred Watson?" We're Space Nuts fans, so shout out to them. Hello. Yeah, and the great thing about Whitehorse, of course, is that, as I said, it's subarctic. And so they do get the aurora there. They get the northern lights. And we did spend 3 nights aurora hunting. We were quasi-successful. We saw the northern lights on, some of us saw them on all 3 nights. But they weren't spectacular displays. There were green streaks in the sky. What pleased me was that I now know how to use my iPhone to take photographs of the aurora. So when we go up to Lapland next year, I shall be armed with the iPhone and something to stand it on so we get dramatic images, hopefully to bring back to Space Nuts.
Rusty from Donnybrook taught me how to do it. So this is on an iPhone. So I don't know if you can see that, but you press that little up arrow.
Yeah, you do.
And and then there's a little moon icon there.
That's right.
And that gives you the capacity to, increase the exposure time and things like that. Yeah. He sent a photo of the sky from Western Australia and the stars the other day. Brilliant photo. Amazing.
Yeah.
All with an iPhone.
All with an iPhone. I know, it's extraordinary. So that was great. We actually caught up with the Whitehorse Astronomical Society as well, which has 22 members, but they've got a lovely observatory out there in the bush. We spent a night sky watching there, waiting for an aurora, which turned up actually just after we left, but some of our group saw it, so that was great. From there, it was down through the ice to Jasper and Lake Louise, places which are extraordinary in terms of...
Was it still frozen when you saw it, Lake Louise?
Yep. Lake Louise was frozen solid, yeah. It was.
Were people being bullfeds and walking out on top of it?
Oh, yeah, all over the place.
No, I wouldn't do it.
They were building snow persons on it. We had a sleigh ride actually, which did go over the ice just to turn around at the end of the lake and come back.
Okay.
But, anyway, there was confidence in the thickness of the ice there. We knew from Whitehorse what the thickness of ice was because you could see it in the river. It was best part of 2 feet or something like that, maybe even more.
Yeah.
Anyway,
well, that sounds. Look, having done a similar trip to you only last year, I can. You brought back a lot of memories for me of Canada. It's just the most beautiful place, and as is the northern part of the United States, similar countryside, and just a glorious part of the world. I loved Vancouver. I love Seattle for that matter. They're both in the same vicinity. In fact, I did the shortest international flight I've ever done from Seattle to Vancouver, which was 23 minutes, I think.
Not very long.
No, we spent more time on the tarmac waiting than we did in the air. But yeah, glorious part of the world, and very lucky to live there, except I could not stand your cold. It just does not get that cold here, and I don't want it ever to get as cold as that in my part of the world. No way. But you did go over there for one specific reason, Fred.
The eclipse, that's right. So we took a flight down after we left Lake Louise, we took a flight down from Calgary to Houston. And the first thing that I got was email from the Anglo-Australian telescope, which was more or less, Houston, we have a problem. Which they did with the mirror elevator at the telescope, which was rapidly fixed, I have to say. But it was very odd that as soon as I arrived in Houston, I got this email. I paraphrased it as Houston, we have a problem. Of course, the space center there, mission control, we took in all that. We took in the Houston Museum of Natural Sciences, which is an extraordinarily good museum. Then took in sort of via San Antonio up to Dallas and Fort Worth. And it was from there that we made our eclipse expedition. We saw the eclipse at a place called Bristol, which is the name of a big town in the United Kingdom, but it's also the name of a little village not very far from Dallas, probably an hour or so from Dallas. And there's a winery there, and that's where we had our eclipse location. We were one of about 100, there were 100 people there or so. We were quite a large group among that. And our group had a wonderful morning waiting for the sky to clear because it was cloudy. We could get glimpses of the sun. We could see after 12:22, which was the time of first contact, we could see the moon's disk starting to slip across the disk of the sun. Totality was at 1:40 Texas time. And at about 1:39, the sky cleared completely. The whole sky just cleared. It was astonishing. And so we were in this completely blue sky for the total eclipse, of which we had 4 minutes, 23 seconds. It was a long eclipse. Very dramatic, lovely views of the corona. I didn't bother trying to take photographs because I know I'm rubbish at it. But I had binoculars, got some great views of the corona, some very prominences, as they're called, these pink blobs that are clouds of glowing hydrogen being pushed off the surface of the sun into its inner atmosphere, the chromosphere. All that was really dramatic. We saw Bailey's beads, those little gaps where you're seeing the sun itself through valleys on the moon's surface. We saw the diamond ring effect, which is just a big version of that. And then the eclipse was over and everybody cheered and we were very happy. And all of those people who weren't about to talk on TV like I was had lots of glasses of wine at night. I didn't touch any till the evening because
it's funny you should mention that, because I was on air on the radio at the time and I glanced up at one of the TV news services and there was Fred Watson. I thought,
seriously?
Yeah. I was on air when it happened. So I saw you talking on Sky News here.
Yeah, that's no serendipity, that.
Yeah.
And there was another couple at the winery who were Space Nuts fans as well. I didn't get to talk to them, but Marnie did. They
marvelous.
Very well aware of Space Nuts.
I was certainly jealous because I would have loved to have been there. But if I'm patient enough, I won't have to go anywhere because in 2028 we get our own right here in Dubbo. Total eclipse of the sun at 1:52 p.m. I think it is, and it'll be it'll be about then. But it'll be 3 minutes and 52 seconds of totality.
In Dubbo, okay.
Yeah.
Yeah. Well, after you've seen it in Dubbo, that the moon shadow will be right overhead here, where I'm sitting now in northern
Yes, it will,
Sydney.
because it's going to come across from the northwest of the state over central New South Wales, and it's going to totally black out Sydney, like it did in Melbourne in 1970, whatever it was.
I think it was 73, was it? Something
Yeah,
like
yeah. I was quite young, and they wouldn't let me go outside. I so wanted to see it, but yes, not advisable without protection. And these days, of course, you can buy sunscreen and rub it in your eyes, and that solves the problem. No, don't do that. Don't do that.
No. That's, I think that could be misinformation there, Andrew.
Yes, could be. Yes. Just ignore that. No, don't put sunscreen in your eyes. But yes, you wear proper glasses and filters and all that sort of stuff. And can't wait. 2028. That should be very exciting. But great trip by the sound of it, Fred.
Yeah. Sorry, go on.
Yeah, I was going to say, on a scale of 1 to 10, what's your rating?
Oh, about 12. We wrapped up with a flight down to Orlando from Dallas Fort Worth, where we took a trip to the spaceport to Cape Canaveral, and our hotel was such that we had a view of the whole of the launch area. And in fact, it was one of those things where you're racing against the clock, because the Dallas Fort Worth Orlando flight was delayed significantly, and we knew there was a launch coming up around midnight. Okay. And we had a coach transfer from the airport, so we got in, I don't know, 9:30 or something like that. Hurled ourselves into this coach to get to the hotel, and made it just in time, except that they delayed the launch, and so it was originally 12, but eventually it was a SpaceX Falcon 9. Its registration in terms of Starlink satellites, which it was launching, was 648, and so we saw it very, very clearly from our hotel, which had a viewing platform especially for watching space launches. They're all set up there. Yeah, so I got the binoculars out again. I didn't try and photograph it, but very spectacular, marvelous thing to happen. Some of our number actually followed it right through to when the first stage was released. The second stage went on its way. First stage turns around to come back down. By the time we'd finished watching, it was already sitting on a barge in the Atlantic Ocean. This must not go beyond these four walls, Andrew, but I had the binoculars on, and there was cloud there, so the rocket exhaust, or basically the fiery exhaust of the Falcon 9 disappeared into the clouds, and then it reappeared, and I thought, that's fantastic, I'll watch for the second stage, parting of the two components. Watched and thought, it's funny, it's not really moving, there's two bright stars on either side of that rocket launch. Then the penny dropped. I was looking at the star Antares in Scorpius, the Scorpion, which looked exactly like the exhaust of this Falcon 9. So I sort of put the binoculars quietly away and said, yes, that was fantastic, wasn't it? Yeah. Anyway.
Rocket scientist, Fred, that's for sure.
It's actually the second time that's happened, because I remember once decades ago it was in Gunnedah, which is in northwestern New South Wales.
Yes, just up the road from us.
Not very far from you. And I was waiting to meet somebody off a coach during the night. And basically was standing outside the bus station at night, and this flaming red object passed overhead, and there was a coach driver standing next to me, and I said, look at that. I said, that looks to me like a re-entering bit of space junk, because you can see that it's fiery, it's red, it's coming in at quite a high speed. I reckon that's what it is. And he said to me, actually, no, it's not. He said, it's a garbage bag with a firelighter tied underneath it. And some kid's been launching these things, and the police are trying to find out who he is before he sets the whole town on fire. So I told him what I do for a living, and he almost wet himself. He was so amused by the fact that
that's brilliant. That is brilliant. Yeah, I love it. Of course, Gunnedah, home to the 150th time, 150 degree time meridian. Is that it?
It's yes, I think it's 150. I think that's right.
Yes,
Yeah.
I thought it was the 150
that's
degree
right.
mark. Yeah, yep. Very good. All right. Now, do you want to talk about the space junk now, or do you want to leave it till the next?
No, let's just mention it because
Yeah. Okay.
it's as you said, it's in the same neck of the woods. This is a story
Yeah.
about a gentleman in actually it's one of the seaside cities in Florida, Naples, and he basically had something come through his roof,
Yeah.
which didn't cheer him up much. But when he looked at it, this gentleman is very astute about space technology. He reckoned it was part of a pallet, basically a support pallet, used to mount batteries, which are being basically re-entered to burn up in the atmosphere. And it was a piece of metal round about 4 inches, 10 centimeters by 1.5 inches, or 4 centimeters, weighing a bit more than half a kilogram, 1.6 pounds. And yeah, sure enough, that was what's gone through his roof. It's been analysed. It was well burnt up, actually. You can find this story, by the way, on space.com. Very nicely covered there with some pictures of before and after for one of these stanchions.
Oh, yeah. Look at that.
Found. Yeah.
Wow.
So
that came off the International Space Station.
Yes, it basically was something that was being thrown away from the International Space Station. It was junk, junk that was being basically being allowed to burn up in the atmosphere. And normally that sort of thing burns up completely, but sometimes it doesn't. And in fact, I think the space agency itself, NASA, have launched a bit of an inquiry to find out why that did not burn up in the atmosphere.
Yeah, that's a strange one. Gosh, it's a good thing it didn't hit a person. That would have made a mess.
That's right. Yeah. So far, nothing's.
The odds are remote, but it's not impossible. But space junk landing. Yeah, Naples, Florida rang a bell. I think they play a PGA Tour golf event in Naples, Florida every year. Yeah.
There you go. And talking about the ISS has just reminded me of one of the real highlights of the trip. You know, I've talked about the spectacular ones, but the Kennedy Space Flight Center, where we went the day after we'd seen the Falcon 9 launch. Utterly mind-blowing. It absolutely took my breath away. All my favorite bits of space hardware there. Yeah. I've got so many photographs now of me standing in front of the Gemini Titan combination, which I
at the rocket park.
Yeah, that's right, the rocket park. Yeah. Thrillingly, I was thrilled by all that while I was a university student in the 1960s, and it just brought it all back. It was fantastic. But the thing that surprised me most, Andrew, you know that the Space Shuttle Atlantis is there at Kennedy Space Flight Center. In the same enclosure is a life-size replica of the Hubble Space Telescope. And for some reason, yes, I know it's a 2.4 meter telescope, but I just hadn't expected it to be so big.
Oh, wow.
Huge. It is huge. Yeah. And yes, it's a big telescope. You know, you've got the tube, which in all the photographs we see of it deployed in space, it looks relatively small, but that thing's 10 feet in diameter, effectively. It's nearly 3 meters or thereabouts. And the instrumentation package at the back is much bigger. So it is a very, very large piece of kit. And yes, it kind of really enhanced my appreciation for the fact that it was taken into orbit by a space shuttle in its cargo bay, and just what I think it's the biggest thing that they ever put in the cargo bay, I think, with about 1 inch to spare on either side of it. So yeah, really remarkable. That was one of those epiphany moments that I didn't really expect. I would have thought, I knew that the Hubble Space Telescope was big. I didn't realize just how big it is. And of course, the James Webb Telescope is even bigger, much, much bigger, with a 6.5 meter diameter mirror. Yeah. Anyway, enough of that. I'm sorry, Andrew.
No, that's okay. No, it's, we can live through your travels and enjoy them almost as much. But I must say, the Kennedy Space Center, mind-blowing. Yeah, just
can I add one more footnote to it?
Yeah, go for it.
It was even more special for us because we had a guide. We had a friend of a friend, Kerry Doherty, in Adelaide, used to work at the Powerhouse Museum. She was the Powerhouse Museum space specialist,
Wow.
very well known in the Australian space world. She has a friend called Tim Gagnon, and she basically got her friend Tim, who works in the Kennedy Space Center, to give us a personalized tour. Now, Tim is a very special individual because he is a space artist, and he has designed 19 of the mission patches that have flown with astronauts, mostly on the space shuttle, but others as well. So his artwork has been in space, and as he works with astronauts to say, what do you want on this artwork?
Yeah.
An extraordinary man. And we've got to get him on Space Nuts, Andrew.
Oh,
because
please.
he's
Maybe he could design us a mission patch for Space Nuts.
Hey, now you're talking.
Wouldn't that be cool?
Now you're talking.
Although I think the logo might. Yeah,
Got one.
that's my brother's design. I like that. I love those two little characters. I think it's terrific.
But yeah, getting Tim on the job would be remarkable.
Indeed.
I know many of our listeners can't see this, but I'm going to show you something anyway.
Well, you can see it on YouTube, and don't forget to subscribe below. I got it in there.
When he said goodbye to us,
Yeah.
Tim knew that I was a mad keen fan of the Gemini missions, which preceded the Apollo missions. There were two-person spacecraft, and there were 12 missions, all of which were about learning how to dock and rendezvous and things like that. So Tim knew I was keen on it, and actually the day after we saw him, he came specially to our hotel to give me this.
Yep.
Which
Look
is
at that.
a kind of
Gemini
giant
2
mission patch for Gemini 2, that's right. But all the other ones around the edge,
look
going
there,
the wrong way around. 1, 2, 3, 4, 5, 6, and 7 flew together, and 8, 9, 10, 11, 12. 12 is that one there. So that's a giant-sized mission patch, which is going to be in a frame and on my wall here in the office before too long.
Why
Wasn't
not?
that great? What a
Magnificent.
gracious and talented and knowledgeable man. It was a delight to be with him. So heads up to you, Tim. Thank you very much for that.
Incredible. All right. We'll leave it there, but you're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
Houston, Tranquility Base here. The Eagle has landed.
You're listening to Space Nuts, the podcast about astronomy and space science with Andrew Dunkley and Professor Fred Watson.
Now, Fred, to something extraordinary. We probably get more questions about black holes than anything else, and they are in the news all the time. And a new piece of information that's now been brought forward, and I've heard this on the news in the last day or so, and this is basically the most massive stellar black hole yet found in our galaxy. Would that be the right way of describing it?
Perfect. That's exactly
Good.
what it is. That's right, and it's great because, it's got strong connections with Australia, not direct connections, but they are there. The original discovery was made using the European Space Agency's Gaia spacecraft, and I'll explain how that happened in a minute. Gaia is an astrometry spacecraft measuring the positions of stars very accurately, but the follow-up work was done with the VLT, the Very Large Telescope of the European Southern Observatory down in northern Chile at Cerro Paranal. The telescope that, in fact, it's 4 telescopes, but they can be used in combination or singly, 8.2 meter mirrors each one. Those telescopes are accessible by Australian astronomers because of the strategic partnership that we have with the European Southern Observatory. So it's a good news story, not just from the science point of view, but from the fact that we can brag about, what is effectively Australia's national optical observatory, not on Australian soil, but down there in Chile, because we have this partnership. So it's a good news story. So what's the story? What's the story, Fred? I hear you say.
There's a big hole in the sky. That's what it is.
Yeah, well, that's right. So what happened was scientists who were working with the Gaia mission. So this is, as I said, it's an astrometry mission. It measures the positions of stars in the sky very, very accurately. Working, these astronomers are from institutions in Europe, notably l'Observatoire de Paris, Paris Observatory, very nice building as well as a nice institution. They noticed that one particular star had a wobble to it that was, detected by the Gaia spacecraft. So this thing's measuring star position very accurately. If you do that over time, you can tell if a star is moving or wobbling or doing something funny like that. And they analyzed the wobble spectroscopically using the Very Large Telescope, and realized that what was happening to this star is that it was in orbit around something else that was invisible. And their calculations showed that this object had a mass of 33 times the mass of our sun, which makes it the only candidate that it could be is a black hole, but it also makes it a record breaker because the next most massive stellar mass black hole in our neighborhood. I put Geordie in here so he wouldn't do that.
All quiet in the studio audience, please.
Yeah. Hello, everybody. Hello. Yeah.
It's all happening.
Yeah, it's all happening. So the next most massive known is 21 solar masses. That's Cygnus X1. It's a very famous, one of the first black holes ever discovered. This one is 1.5 times the mass of that, 33 solar masses, quite exceptional. There are more massive black holes in other galaxies, but this is significant because it's in our own galaxy. It's only 2,000 light years away. And it's challenged our understanding of black holes, because remember, we're talking now about stellar mass black holes. That means black holes with a mass of about one star, so 33 in this case, which are ones that have been formed when a star gets to the end of its life and collapses. So they're not the supermassive black holes that we think about in the centers of galaxies. They are probably formed by black holes accreting together, building up a very, very solid array of a very solid mass of black holes, sometimes billions of times the mass of the sun. But in the stellar mass region, this is a record holder within our galaxy. And as I said, it's challenging astronomers' understanding of how something this massive could form, because typically they're 10 solar masses, something like that. How could you get something as massive as this? And a clue comes from the companion star, which may well have been formed at the same time as the progenitor star of the black hole, the thing that was the star before it exploded and created the black hole, because it's highly metal poor. And as you know, everything except hydrogen and helium to an astronomer is a metal. And this star is very metal poor. It means it's mostly hydrogen and helium with not much else. And that makes it a bit different from your normal star. Most stars have got quite significant amounts of other elements in them, like sodium and carbon and oxygen and iron and all of those things. Whereas these metal poor ones have only very small amounts of that. And so maybe it is something to do with the fact that the companion star and almost certainly the progenitor star of the black hole were metal poor. That might be a clue to why we have this not supermassive black hole, but very massive stellar mass black hole in our own galaxy.
The other theory I have is it's actually 33 1/3 times the mass of the sun, and it's not a black hole, it's just a vinyl LP.
Now you're talking. No, I hadn't made that connection, Andrew, and I have to say it is a fairly tenuous connection. The one link that I thought it was credibility. The one link that gives it some credibility is that vinyl LPs are black.
Yes, that's right. Yes, that's the only connection I was making, really. And kind of the same shape without the hole. Oh, now they've got the hole in the middle. Yeah, that's
definitely got a hole in the middle. I suppose you could equate the edge of the vinyl to the event horizon of a black hole. That might be,
It's just a thought. Just a thought. But yeah, quite an incredible discovery. Makes you wonder if there's anything potentially bigger out there in the stellar mass black hole arena.
Yeah, I mean, the reason why we haven't known about this before, because it is close, much closer than Cygnus X1. It's because it's quiescent. It's not gobbling anything up. because that's what normally gives them away. If you've got the accretion disk, which is swirling around the black hole, you're going to get radiation from it. And that's what we normally discover, but not in this case. It's the wobble of the star.
It's like finding a volcano that's been there for billions of years and you only just notice.
Yes, that rings a bell too.
Indeed. All right, Fred, we are done, but a reminder to everybody, if you're particularly watching us on YouTube, to subscribe, which you can do that down there, one of those finger points to the subscribe button, so please do that. Don't forget to visit our website and have a bit of a peruse. I love using all these weird words. And don't forget our social media platforms as well, the Space Nuts official Facebook page, and of course the Space Nuts podcast group, which is getting more and more active and more people. I think more people are on that Facebook page than actually ever listen to us. But it's a great fun page where you can all talk to each other and swap photos and yarns, and it's a good time place. Fred, we are done for another day. Thank you so much. Good to have you back in person. We've kind of been in pre-record mode for the last month or so, but we're back and things will be normal for probably a week or two.
Yes, that's right.
Before someone else goes overseas. I wonder who that'll be.
Who knows?
Yes. All right. Thanks, Fred. See you soon.
Cheers. Thanks very much, Andrew.
Fred Watson, astronomer at large, part of the team here at Space Nuts. Good to have Hugh back as well, although he's forgotten how to do everything. And from me, Andrew Dunkley, thanks for your company. Catch you on the next episode, a Q&A episode of Space Nuts soon. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Complete Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
Okay. One down, one to go.
Sounds good.
Now, I've got my questions lined up. We're going to go audio, text, audio, text. Couple of them probably be quick and easy, and I think the first one's pretty heavy duty. But we'll see how we go. Try not to take too long.
They're the only thing keeping me from my coffee.
Yes, I had mine before, so that's easy. All right, so we might as well just get stuck straight in.
Sounds good.
In 3, 2, 1. Hi there. Thanks for joining us again on Space Nuts. This is our Q&A episode, and we are great. I'm going to start again. Sorry, Hugh. I don't usually do that, but I'm out of practice.
Yeah, I am too.
3, 2, 1. Hi there. Thanks for joining us on another edition of Space Nuts, our Q&A edition. I'm Andrew Dunkley, your host. Great to have your company. And on this particular episode, we're going to be looking at black holes. Shocker. We never get black hole questions, but this one's pretty involved, and lots of sort of moving parts to this question, so it might take a little bit of unraveling. We also have a question about supernova and the elements they create. Why is it so? How is it so? The Fermi paradox has been brought up, and we're going to talk time travel and magnetospheres, all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And clearing his voice to get things going with this edition is Professor Fred Watson, astronomer at large. Hello, Fred.
I should learn where the mute button is, shouldn't I, for that sort of thing? You know,
I don't even know if I've got a mute button. Hang on. I think I have. No, I haven't.
Yeah, don't press it. We might not get you back.
Yeah, I'm not game. That's the problem with digital technology.
Exactly, yes.
How you been since I saw you last 5 seconds ago?
You were very well, thank you. Still head in the clouds because of our North American tour of all the spacey things you can think of in North America.
Yeah, it's a lot of spacey things there, and there are plenty of them all over the world these days. It's
Yeah, that's true.
been
That is
a
true.
big growth industry.
Even in
We've got
Australia.
some, yes, very true. Yeah. We've got some questions to try and answer, and I use the word try loosely. Let's get stuck into the first one. Now, this is a pretty involved question, so we'll be back in 20 minutes, but this comes from Jose.
Hello, fellow space nutters. Jose here from California in the United States. Love your guys' podcast. I listen to it every day at work. I know I got to get a life. Sorry. But I was listening to an episode one day where you guys were talking about possibly, or a theory that you guys were talking about where possibly universes could exist inside black holes. And it got me thinking that, this would explain a lot of the mysteries of the universe. For example, the Big Bang. The Big Bang could have just been a supernova explosion from a star in an alternate universe, which gave existence to our universe. And I was also thinking that as a black hole, I guess, as the event horizon grows, that is actually our universe expanding. And the reason nothing can escape a black hole is because you would have to be traveling faster than light, which is not possible unless you're, the expansion of space. I guess that travels faster than the speed of light, and the material that gets sucked into a black hole, that all gets converted into dark energy, which is the energy that we can't see, or I guess the expansion of the universe that we could see. But, I was just thinking about all this. I was completely sober, mind you. I wasn't doing anything, but I know this is all speculative. I just wanted to get your guys' point of view on this. Do you guys see this as possible, impossible, feasible, or I'm just completely crazy? But also wanted to get your guys' opinions on what you guys believe is beyond the event horizon of a black hole. Just speaking without any proof of anything, just ideas, what you guys believe. Do you guys believe, there's a white hole at the other side? Do you guys think there's nothing? Maybe you just, you just die if you go inside a black hole. I don't know. But let me know what you guys think. I'd love to hear your guys' answers. Keep up the great work, and I will be listening to you guys nonstop. Go Space Nuts.
Oh, that's lovely. I can't help but I've got to do it. The answer is no way, Jose. Couldn't help myself. Dreadful. There were lots of bits and pieces in that one, Fred. I've sort of written down some notes. Big Bang, created by a supernova, which created our universe. I venture to say that's probably, I think that theory's been put forward before, but was the Big Bang caused by a supernova, which means there had to be a preceding universe before ours, I imagine. What do you think?
I'm thinking that
I can tell you're thinking.
What Jose has described sounds a lot like some of Roger Penrose's ideas, the Nobel laureate, who got his Nobel Prize for proving that black holes can exist. So he's well and truly in tune with this, but also has a theory of a kind of cyclic universe, which does involve the Big Bang effectively coming from a black hole. Now, I was just looking online there to see if I could find some, pithy words from Penrose that talk about this. I do remember some years ago, I ventured into his book on this topic, the kind of multiple black hole universe theory, which is the same shape as a brick, Andrew. It's a very, very thick book indeed. And it's in two halves. The first half is all the mathematics you need to understand the second half.
Yeah.
So it left me not exactly reeling, but I'm always confronted by hard mathematics. It nearly cost me my degree back all those decades ago at university. So I didn't plough into it very deeply. But Penrose is, I think what Jose is talking about are very similar to some of Penrose's ideas.
Okay.
He is, it has to be said, a maverick in his view of this kind of cosmology. His work is, I would say, viewed with certainly his work on the multiple universe and the idea that big bangs spawn black holes spawn big bangs. I have to say that is at the sort of more speculative end of the way astronomers view our understanding of the universe. We really don't have any direct evidence of there being any other universes. And in the Penrose theory, and I suspect in the ideas that Jose is putting forward there, what you end up with is multiple universes, because you're inside a black hole, and black holes are 10 a penny. They're commonplace, as we know. So he asked what our view of this is, and mine is. It's as I am on many things, open-minded, but recognizing that mainstream cosmology does not see us as being within a black hole that was spawned in some sort of higher dimensional space or in some kind of multiverse scenario. So I follow this with interest. I probably should have read up a little bit more on Penrose's theory than I did, but I encourage Jose to go online and check out what Roger Penrose's model of the universe is. There will be fairly easily digestible versions of it online. Don't go and buy the brick that takes you 12 years to read because you spend the first 6 trying to understand the mathematics. I think that's
indeed
very much one for
What about
specialists.
the dark energy theory as to where that comes from? Black holes creating dark energy. I got a feeling I heard some theory or some study that came out that said there's some relationship, but I can't remember the details.
We actually covered it on Space Nuts.
Yes.
So, and once again, that is an interesting idea that I can't remember the details. It's kind of about the equation of state and things of that sort. But it was suggesting that black holes are the source of dark energy, and the mechanism I can't remember. But let me just put one other issue into the the conversation about this, because it looks as though with very recent studies of the geometry of the universe, looking back over billions of years as we can do, that maybe the dark energy is not behaving in the way that we thought it was. In fact, we covered this as well on Space Nuts, and this is to do with the equation of state. That the number is not, it was thought to be -1, which means that the dark energy is what we call the cosmological constant. It's constant throughout the history of the universe. So as space gets bigger, so does the dark energy. But that relationship between the volume of space and the amount of dark energy is constant throughout the history of the universe. It may well be that that's not true, because the new evidence seems to point to it not being. And that might once again feed back into theories like the one that Jose is talking about, where you postulate the idea of a black hole being or the universe being within a black hole. My issue with that is, where does it all come from? So if you've got stuff being sucked into a black hole from outside the universe, where's it coming from? And that naturally leads you to ideas of multiverses, which, as I said, are definitely not mainstream at the moment, although people are open to them, including indeed the Astronomer Royal in the UK, who I think coined the term multiverse quite some time ago.
Yeah. And his final point, what's beyond the event horizon? Could it be a white hole?
Maybe. I mean, that's what I'm just saying. In order to have something beyond, if the whole universe is within an event horizon, you've got to have something beyond it. And that leads you into multiverse theory. And white holes might, yes, a gigantic white hole might be another kind of universe that doesn't have dark energy in it.
Yeah.
Great thinking, Jose. I like your thinking, and very nicely put in your recording there.
Thank you, Jose. Lovely to hear from you. We've got a question from Alan. I've been reading about the gigantic supernova detected by the James Webb Space Telescope and how it has cast doubt, amongst other things, as to whether supernovae are always or at all the creators of heavy metal elements like gold. This has revived a long-standing question I've had in relation to gold and other elements found in distinct extractable concentrations on Earth. How did such concentrations form out of the totally chaotic molecule soup of a supernova?
Nice question. Yeah,
I thought it was beautifully written, to be honest.
And just covering the first bit of that, yes, we now think that gold might be produced by neutron star collisions as well, what are called kilonovas, things that are a bit less than supernovas. So gold, but the bottom line, either way, whether it's supernovae or neutron star collisions, you've still got, exactly as Alan says, this chaotic distribution of these elements throughout space. When a supernova explodes, you've got them being created in a mishmash with lots of other elements. And so the way we find them in concentrations is as we do on Earth. We find gold in, not just at one atom at a time, but we find it nuggets at a time sometimes, or in other forms. The mechanism to create that really involves planet formation. So you've got this cloud of dust and gas, which is much of which is enriched by elements like gold in the cloud of gas. That condenses to form a star and its planets. So the important thing here is that gravity now plays a part in it, because gravity is pulling the heavier elements together. If you've got what we call protoplanets and planetesimals, which are their precursors. Planetesimals are basically baby planets in a swirling disk of dust around a star, which we call the protoplanetary disk. So those planetesimals are pulled together by gravity. And so if you've got gold, that tends to concentrate as it's pulled towards the middle. All the heavy elements are pulled to the middle. And this is a process we call differentiation. And then what happens is another planetesimal bashes into this one, and it's smashed into smithereens, and then goes to form another, slightly bigger body. And eventually you've got a planet. And eventually you've got a planet with stuff in its crust that has come from these concentrations within planetesimals. So I think that's the process that Alan is looking for, why we get concentrations of these materials in the crust of a world like planet Earth.
There you go. Thank you, Alan, and fantastic question. Thanks for sending it in. This is Space Nuts, Andrew Dunkley with Professor Fred.
Roger, you're live, sir, here also.
Space Nuts.
Now we'll go to our next question, and this one comes from Justin.
Hey guys, it's Justin from Brisbane. I listen to your show habitually, and I think you do a great job. My question's about Fermi paradox. And from what we can see, every new discovery of every planet that we find, every planet seems to be so much different from the last one, and then the next one's different, and then we're finding things that we've never seen before all the time. So isn't it becoming more and more likely the more planets we find that aren't like Earth, that Earth is totally unique in the universe? Is that becoming more and more of a possibility the more we look? Thanks, guys. Like I said, great job. Love your show.
Thank you, Justin. I love this question because it does throw up that possibility that every planet could be unique, and and the more exoplanets we find, the more weirdness we seem to witness as a consequence of that. However, then you look at some of the moons that are within our solar system, and the similarities between some of them are quite stark, like Europa and Enceladus. So it stands to reason from my perspective that there probably are other planets in the universe that are maybe not identical, but quite strikingly similar to Earth or Mars or Venus or Jupiter, or you name it. It just, I think there'd just be too many for them to all be absolutely and utterly different from one another. What do you think, Fred?
Yes. So we have discovered. Sorry, I just had a coffee delivery there.
Yeah, I saw.
We have discovered planets that are Earth-like in the sense that the size of the planet, its mass, its diameter is similar to Earth, and we might well discover more because Earth-like planets are not that easy to find. They're the smaller end of the planet range. So it was when we started discovering exoplanets at first, there were all the big ones because they're easy to find. So we may be missing a lot of Earth-like planets, but I basically do agree with Justin because we think Earth-like planets are relatively rare, but then when we look at our own planet, we see not just that it's an Earth-like planet, which it clearly is, but it's got other really interesting quirks about it, like a massive moon that may well have stabilized its rotation over very, very long periods of time. And so all of that comes in to sort of direct your thinking to the idea that maybe the sort of environment that we've had that has allowed life to flourish, and in particular to take that step from single-celled to multi-celled organisms, which we think could be a very energy hungry process and therefore very rare. When you look at that, you begin to wonder just how unique we are, and well, you can't really qualify uniqueness, can you? But you know what I mean? We are probably unique, and it may well be that that's one of the reasons why we're not seeing alien life everywhere. Astrobiologists are fairly convinced, I think, today that yes, you can probably get single-celled organisms forming relatively easily if you've got the right conditions, but it's much more difficult to produce multi-celled organisms and to go on from there to vertebrates and all, primates and all the rest of it.
They're giant leaps.
They're all giant leaps. And I think that in itself is the answer to the Fermi paradox, that if there are species like us elsewhere, they are so far away that you might as well forget them. We might be alone in our galaxy, for example.
Although I've been watching the 3-Body Problem series on TV, and those aliens are way too close. So, in fact, it's prompted me to buy the book because I know it's a Chinese book that's translated to English, but makes it a bit difficult to read. But, not difficult to read, but totally different setup because it's been Americanized for television. So you've got to get your head around that. But I'm really enjoying it. I don't know why I mentioned that. But thank you, Justin. And because it involved aliens, obviously. Let's go to our final question. We'll be real quick on this one. Hello again from James. I've got a couple of hypotheticals for Fred. Oh, thank goodness. If we could travel in time in reverse in the same fashion as going forwards, would gravity behave in the reverse like you can mathematically reverse a black hole into a white hole? And question 2, if in the future we have a strong enough power source, could we travel to a metallic body such as Psyche and put some form of electromagnetic generator at opposite ends of the body and generate an electromagnetic current through the asteroid or even a planet to generate an asteroid planetoid magnetosphere. Thanks for entertaining my nonsense, James.
Yeah, actually, Psyche might already have a magnetosphere. Because it is metallic. There may be residual magnetism in there. So the answer to James's second question is probably yes, that, if you were naughty enough to think about doing that, it may already have a magnetosphere. We'll find that out when Psyche, the spacecraft, gets to Psyche, the asteroid. I can't remember when it is. I think it's in a couple of years' time, if I remember rightly, something like that. It's on its way now.
Yeah.
So you're going to look it up for me, I hope. And the first question, that's an interesting one. If you
late July 2029.
There you go. Thank you. So 5 years' time.
Yeah.
To talk about reversing time,
yes,
time, the arrow of time goes forward for us. And we know that the physics are symmetrical, so that you could reverse the arrow of time, and if you do that, you get white holes rather than black holes and things of that sort. But I don't know that you get negative gravity. That's a really interesting one. I'd have to think about that and maybe look up some of the equations. Negative.
I can't imagine you could reverse gravity like that. It's such a dominant force, and it seems to kind of be like we know what it is, we know what it does. It can bend things like light, but it just I can't imagine that you could equivalently flip it on its head. It just doesn't seem.
Yeah, I mean, just thinking further along from that. So we imagine that there are particles called gravitons that carry gravity. This is quantum theory that is not yet proved, but they're hypothetical particles. But they are probably what's the name for them? Is it unipolar? It's something like that. They've only got one sign. They're only positive. It's like electrical. So electrical charge, you can have positive, negative. Magnetism you can't, which is odd. You can have north and south poles, but that's slightly different. The graviton is probably something that you can't have a negative version of. So I'm sticking my neck out here and saying that the answer to James's question is probably no.
Probably not. All right. Thank you, James. Thank you to everyone who sent in questions. Don't forget to keep them coming. You can do that via our website, spacenutspodcast.com or spacenuts.io, and just hit the send us your questions tab on the right or the AMA tab up the top, where you can send us text and audio questions. Please don't forget to tell us who you are and where you're from. We just like to know. And I hate to do it. But we've got a dad joke from Misty, who's listening in live today. There she is now. How did you get your number, Fred? What did the black holes say when they collided?
Go on.
Nothing. They just waved.
Nice one. I like that.
Yeah, clever.
Very good.
Indeed. Good. Yes. All right. Thank you, Fred, as always. Great to catch up again, and we will talk to you again real soon.
Sounds good. Thank you very much, Andrew. I think I'm probably missing another meeting, so I should skip off now because there's another one going on next door. We'll talk next week. We'll
for sure.
The date. Yeah.
All right. See ya. Fred Watson, astronomer at large, and thanks to Hugh in the studio for being Hugh in the studio, because he's the best person in the world at being Hugh in the studio. And from me, Andrew Dunkley, thanks for your company on this episode. We'll see you next time on another edition of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
I've completely lost my place.